Hi, my name is Benjamin Bacon, and I am about to describe to you some of the details involved with implementing the electrical analog circuit to a mechanical system. Before we get started, we would first like to discuss the coupling here in the mechanical system. The coupling can be described as loosely coupled. This system has mass 1 and mass 2 being coupled only by the force between them and a mass flow that can flow from 1 to 2. There are no ground or stationary-like couplings. This system is free to move as a whole or in between this mean free space within the system without any encumbrances. That is the ideal, and that is what we will try to represent in an electrical analog. When we get to the electrical analog, we notice that there is a variance between the models because this electrical analog is a bit more strongly coupled through this ground connection that both of these two blocks share, unlike the situation we have in the mechanical system. So in order to make this a more accurate representation of the mechanical system, we will want to reduce the coupling here. Before we do that, or would be able to do that, we're going to have to discuss this ground symbol. This ground is a specific kind of ground with the plus and minus symbol that is implemented in two batteries connected in series. The plus and minus of the batteries connected on one side, and then on the opposite side of the batteries they're both connected to a capacitor. The purpose of this capacitor is to prevent current from flowing between the two batteries. And I call this ground symbol a DC neutral ground because it provides support for a dual polarity source. And to see that, let's assume that this terminal on the current source is positive, then it has a ground to go to here. And when this terminal becomes negative, it still has a ground to go to. And the same on this terminal. When it's positive, it has a ground, and when it's negative, it has a ground. So this ground lies between the positive and negative voltage. So it is essentially a zero voltage point. And that is implemented in these components. And then you know you have the other components, the C1 to represent mass 1, a capacitor, C2 to represent mass 2, another capacitor, and the differential variable capacitor, which represents the fluid mass M3 that can be either here or there depending on how you turn the shaft on the differential variable capacitor. It represents a mass flow from mass 1 to mass 2 or mass 2 to mass 1. This is the first stage of implementing the electrical analog to the mechanical mass system.